minus 4 by 3, 2 by 3 and minus 2 by 3. Please do it now. Yes, what are you getting?
Then we take A as whole k minus 1 x square or just k minus 1 x.
Yes, Aisha. You will be taking
I'm asking for A we take k minus 1 x square or just k minus 1 x.
A is just k minus 1. A is k minus 1. B is k C is 1. Okay.
Okay.
Okay, let's do it. If one of the zero of the given quadratic equation is minus 3, then we have to find the value of k. Okay. If minus 3 is one of the zero, that
Ma'am,
means it will satisfy. Yeah.
for some alpha plus beta is equals to minus b by I got k as k is equals to beta minus 3 by 4.
K is equals to beta minus 3 by 4.
I don't know if it's correct.
You have taken alpha plus beta is equals to minus b by
Yes.
alpha into beta is equals to c by a, right, Asha?
No, alpha into beta I did not take. Yeah, yes, I did this, but I did not do I did not equate it for alpha into beta.
Okay, so we will check whether this approach is working or not. Okay, taking the sum of the zero, product of the zero,
Okay.
whether it is going to help us to take out the value of k or not. Otherwise, we will use the logic that if it is one of the zero, if it is one of the zero, that means at the place of x we can substitute it and the result will be zero, right? Right? Since
Yes.
minus 3 is one of the zero, minus 3 is one of the zero. Zero, what does that mean? Zero means such a x value which will make the polynomial zero. If I will tell you what is the zero of this particular polynomial x minus 1, you will, without even finding, you will be able to say that x value 1 is the zero of this polynomial. Yes or no? When we will substitute this zero in the polynomial, the result will become zero. That's the meaning of the zero of the polynomial. So if minus 3 is one of the zero, that means if we will substitute this x value, if in case we are substituting this x value, as a minus 3, our polynomial will become completely 0. Yes or no? Yes or no? Are you getting it? And if we will write it this way, is it possible to take out the value of k? Is it possible? Let's check it. K minus 1 minus 3 square is just 9. Minus 3k plus 1 is equals to 0. That means 9k minus 9. Yeah, it is even it is very like simple to take out the value of k from here. No square, nothing. Just a very linear equation we have got, which we have to solve for finding the value of k. Please find the value of k from here. Yes, what are you getting? 9k minus 3k is 6k. Minus 9 plus 1 is minus 8. What are you getting k value? Yes,
4 by 3.
4 by 3. 4 by 3, let's check whether that option is there or not. Yeah, option A. So if minus 3 is one of the 0, then there two things must come in your mind. The first is whether we can use the sum of the 0 and product of the 0, this concept. Okay, this concept, sum of the 0, product of the 0. Sum of the 0 is minus b by a, product of the 0 is c by a. Maybe from there we will be able to do the calculation and we will be able to take out the value of k. Here it was not that simple. Okay, however it will be possible from here. We tried another approach also. Okay, if minus 3 is one of the 0, that means if we will substitute this x value, our polynomial will become 0. That is the exactly meaning of 0 is. Okay, so we have substituted and we are saying our polynomial will become 0, and from there we ended up getting k value as a 4 by 3. Any confusion? Anyone having any confusion over here? Why what we are doing? Why we are doing?
No, no.
Now,
There is one more
is
question.
yes, please tell me.
Value of p for which minus 4 is 0 of a polynomial x square minus 2x minus 7p plus 3.
Value of p for
Minus
which
4 is a 0 of a polynomial x square minus 2x minus, and in bracket 7p plus 3.
so this is also a quadratic polynomial. One of the 0 we know it is minus 4. Okay, and we have to find the value of p. Still two things are coming in our mind. Either let's take this and substitute it over here and write is equals to 0 because it's a 0. So when we will substitute this x value, this x equals to minus 4 is a 0 of is 0 of this given polynomial. That means this particular x value, when you will substitute in your polynomial, the result will be 0. That is the meaning of 0. Okay. So again we are having two options. Let's substitute this x value minus 4, then 2 into minus 4, then minus 7 3 plus 3 is equals to 0. You can see that yes, we will be able to take out the value of p from here. Or the other way is find the sum of the 0, product of the 0, and say that one of the value we already know, maybe alpha value we already know, minus 4 plus beta. Okay, other 0 we have to find? No, Other 0 we don't have to find. We have to find the value of P. Okay. Here, if I will ask you in this particular question, what is A, what is B, what is C? Who will say what is A, what is B, what is C from here? If we will compare it with ax square plus bx plus c, what is A, what is B, what is C? Yes?
A is x square.
No, Aisha. A
A
is the
is 1.
coefficient of x square.
Yes.
A
So it
is
will
1.
be 1.
Yes. B
B
is,
is minus 2.
yes. And C is
Minus 7p. Do we multiply minus with plus?
minus 7p plus 3. This way we can write. Right?
Okay. Ma'am,
This
can
is
we
C.
directly multiply minus with plus 3?
Yeah, we can say minus 7p minus 3.
Okay.
Okay. Or we can say, write it like this. Okay, this is C. So yes, the A is 1, B is minus 2. Let's see whether it is possible to take out the A, like the value of P from here. Sum of the roots formula is minus B by A. So minus of minus 2 by A is 1. From here we will be able to easily, we will be able to find the other root. See, in this particular question, beta value we will be able to find from here. And then this beta and alpha value we already know, one of the root is minus 4, another beta value we will be getting from here, which we can substitute here. And then product of the rule formula is C by A. C is minus 7p minus 3. Directly also you can write by A is 1. So from here also we are able to find the value of P. Can you see?
Yes.
Okay, method 1, method 2. In previous question also, okay, maybe method 1 will work, you have to just check it, but that will be like that will take time to figure it out what can be done. And here easily we are able to take out the other root, but in not like, it's not like this one in the previous question. In previous question easily we are not able to find the value of k or maybe the value of beta. Okay, that's why the other method is the preferable method. We must use the other method only, because otherwise you will end up lacking exam in time, the lacking time in exam, because after the exam most of the student complains that we were running out of time. So you have to avoid this mistake, that you are not going to apply any approach which is not working, and or maybe which is lengthy. Okay, are you getting it?
Yes, ma'am.
Let's continue. Let me give the next question. Okay, so you understood the concept. I was about to give the next question which is just like this question. I am not giving it now. Now the next is, which of the following is a quadratic polynomial with zeros 5 by 3 and 0. Options are 3x, x minus 5, it is 3x minus 5. Option B, 3x, x minus 5. Option C, x square minus 5 by 3. 5 by 3 x. Yes, please do it.
Ma'am, option A.
A. Yes, everyone is getting A. Yes, everyone is getting A. Let's check it. So
Ma'am,
5 by 3 and 6.
I got
Oh,
option
yes.
C.
Okay. Udyan, you got C. Yes, rest of the student, Alpina, Afnan, Ifra, Abdul. Is it A or C or maybe B or D?
I'm option A.
Option A. Okay, Afnan got A. Albina also got it. Let's check it. 5 by 3 and 0. Okay. So if we will take this 2, we'll be able to generate a polynomial. But the question is, like, in front of that, there will be k. I always say that if you know this two zeros, 5 by 3 and 0, you can generate a polynomial that is x squared minus sum of the zeros into x plus product of the zeros. Okay, this is a polynomial, but in front of that k is there. K can be 1, 2, 3, 4, any number, any real number, and all those polynomial, whatever, like k you will be taking over here, every polynomial will satisfy this condition. Every polynomial will be having 5 by 3 and 0 as two zeros. Okay, now the question is, like, what to take as a value of k. So let's write it as it is. We'll be having x squared minus 5 by 3 x, 5 into 3, 5 by 3 into 0 is just nothing, 0. Okay, we are having this one. Now we will try matching, that it is matching with getting with which option, 1, 2, 3, or which. Okay, so we can also write it as a 3x squared minus 5 x by 3 is there still. We can write it like this. Okay, let's match option A. Option C is also not the correct option. Why? Because this 5 by 3 is not having x. If this 5 by 3 will be having x like this, then we could have said that, yeah, by taking k as a 1, this is a polynomial. But this is not having x. Can you see? Adyan.
Yes, ma'am. Yes, ma'am.
Okay, x is not there, so we will not do mistake. So C, of course, C is not a correct option.
Ma'am,
We will be, yes,
ma'am, I did it by some other way.
yes. How you did it?
What I did is 5 by 3 and 0 was given, so I equated in that equation A. Then
And it is
I did it separately, and then I got my answer as 0.
separately you have substituted 5 by 3 and
Yes.
0 x value.
Yes.
Okay.
If you
When
do it
we
with option A, then we get 0, and with other we are getting some other number.
let me check, are we going to get 0 or not? 3 3 got 5 we are having. 3 3 got 5 minus 5. Yes. This is coming 0. If we'll be substituting 0, then yeah, it is coming 0. For the other equation, we are not getting 0. 3 into 5 by 3. This one. 3 into 5 by 3.
No, we won't get.
No, we will not get. Okay, last one also 5 by 3 will not give us 0. So your first equation is satisfying. Yes, this is also the best way to figure it out whether these two are the zeros or not. Zeros means we understand. When we will substitute it in the polynomial, our polynomial, the complete result has to be 0. So yeah, it's like option by option we can check and we can start eliminating the option. Okay, option A is satisfying. 5 by 3 when you will put, it is satisfying the equation. 0 when you will put, when you will substitute 0 in this polynomial, the result, the final result, the final outcome is becoming 0. That is the meaning of 0, right? So yeah, we were following this way, and we will be checking whether this way it will be the first option or not. So we can check 3x is there and then 3x minus 5 is there. We can see x is common and 3x minus 5 will be there in the bracket. By 3 will be there and k value. Okay, k value. K can be any number. 1, 2, 3, 4, 5 by 3, 5 by 2, 2 by 3, only 3. Okay, so it seems like the first is the correct option where k value k value has been taken as a 9. Check it, ध्यान से देखो, k value 9 लिया गया है तब जाके first equation आएगा. Can you see it? 3x minus 5. When we will be taking k as a 9, it will be 3. 3 times 9, it will be 3x. 3x minus 5. Can you see it? Okay, then why I shown you this way? Because here I always say to my student, I always want you to know that there is all k. Okay, without k you are writing that equation is having 5 by 3 and 0 as zeros, but how many such polynomial will be possible? So there are infinitely many polynomial, there are so many polynomial which will give zeros as 5 by 3 and 0. That's why we will always take k over. But for this particular question, your way is the best way to check it. Just take the zeros, put it in the polynomial, and then you
Yes.
are done. Okay,
Yes.
is it okay?
Yes, ma'am.
Let's do the next one. If alpha and beta are the zeros of a polynomial, px is equals to x square plus x minus 1, then 1 by alpha plus 1 by beta equal to, options are 1, 2, minus 1, minus 1 by 2.
Ma'am, option B.
Option B. Yes, everyone is getting the same.
Yes.
Okay. So if how you did it, px is equals to x square plus x minus 1. Sum of the zero you must have found. Product of the zero you must have found, right?
Yes.
Sum of the zero is minus b by 8 and product of the zero is c by 8. So alpha plus beta is minus 1. Alpha into beta is also minus 1. Okay. Now 1 by alpha plus 1 by beta value we are supposed to find. We will be taking the LCM. What will be the LCM over here?
-1.
LCM of this two. Aisha? Is it minus 1?
No, 1.
1 by alpha plus 1 by beta we are having. If we will try simplifying it by taking the LCM, what will be the LCM? 1 or alpha beta? What you did? Tell me. Yes, how you found
Ma'am, I
1
was
by alpha plus
confused in this part, so I thought I should take -1 as the LCM.
yes, rest of the student. Adyan, you also answered that B is the correct option. How you found? Yes, we will try simplifying it. Here LCM is alpha beta. Okay, in numerator it is nothing but beta plus alpha. We can put the values. Beta plus alpha we know it is minus 1. Alpha into beta we know it is just minus 1. And the result is just 1. So 1 by alpha plus 1 by beta's value is just 1. Can you see it? Can you see? Equation 1 and equation 2 we have used. Yes, everyone getting it?
Yes.
Yes,
Okay,
ma'am.
it is just 1. Answer is just 1. Let's do the next one.
can you explain the last part again?
Yeah. See, alpha, beta are the zero of the given polynomial. The given polynomial px is x square plus x minus 1. And this polynomial's zeros are alpha, beta written in the question. So we know sum of the zero formula. We know product of the zero formula. That is minus b by a. Here b value is, yes, b is
One.
1.
1.
Okay, minus 1. And a is
1.
1. So minus b by 8 is just minus 1 by 1. You can say it is just minus 1. Alpha into beta, c by a. C is minus 1, a is 1. Alpha into beta also we are getting what? Minus 1. We are keeping this information in hand. Okay, now what we have to find? We have to find 1 by alpha plus 1 by beta's value. Okay, 1 by alpha plus 1 by beta, this we have to calculate and we have to check, are we going to get 1, are you going to get minus 2, are we going to get minus 1 or what? So what we can do for now, we can do the simplification. Simplification means we can take the LCM. LCM, if I am asking you what is the LCM, alpha is there, beta is there, denominators are completely different, no common factor, nothing. So for finding the LCM, what we do? We do the multiplication. Yes or no?
Yes, ma'am.
Yes.
Now if I am asking you what will be there in the numerators part here in the box, okay, what will be there? So you will compare like this. Here the denominator is alpha. Previously the denominator was alpha, and now the common denominator which we got from LCM is alpha beta. So what extra term is there? Beta is extra. That extra term we need to multiply in the numerator also. This is how we do the addition, right? 1 into beta.
Yes.
Okay. Now we will compare the second denominator. The second denominator is beta, and now our denominator, the common denominator, became alpha beta. So what extra is there? Alpha. So that alpha we need to do the multiplication in numerator also. In numerator 1 was there. We are multiplying alpha with it. And hence it became beta plus alpha in the numerator and just alpha beta in the denominator. Now equation 1 and equation 2 we are having in hand already.
You are
Equation 1,
having. So
yeah,
substitute the value.
yeah, and we will get 1 by alpha plus 1 by beta is nothing but just 1. Is it clear to everyone? Is it clear? Find the zeros of quadratic polynomial. 6 square minus 13x plus 6. Please find the zero. Yes, are you done?
Ma'am, I got alpha plus beta is equal to 13 by 6 and alpha into beta 1.
Zeros you have to find, Aisha.
Ma'am,
Splitting the
but
middle term,
how to split it? It's 13.
6 times 12. When you will multiply A into C, you will be getting 12. 12 1 times 12. And 12 and 1 together making 30. Check it. Yes or no, Aisha?
Yes,
Getting it? 6x we will take common. Remaining will be 6 minus 2. Is it 6? It's not working, right? Wait. How can I take 6 into 6 as a 12? It is 6 into 6 is 36. Wait, it's wrong.
Ma'am, 9 into 4.
Yes, 9 into 4. And 9 and 4 are making 13 as well. Yes, perfect. We got it. 6x square minus 9x minus 4x plus 6. Okay, it is 6. I thought that it is 2, 6 into 2, 12 I have taken. No. Now common factor from the first two term, 3x. Okay, 3 2 times 6, 3 3 times 9. And from the next two, minus 2. Okay, 2x minus 3. So yes, we got x values. We'll be able to find from here 3x minus 2. The first x value is 3 by 2, next is 2 by 3. These are the two zeros. Yes or no?
Yes, ma'am.
Okay, so